Yes. So now what we were discussing, I think we had already discussed about the curves for concrete and steel, right? So now we will just discuss about the types of limit states. Okay. So when we are talking about the types of, so when a structure is failing, so either it can fail by collapse or it can uh, become unserviceable. So these are the two things which we have. So on the basis of that, we have classified as limit state of collapse. So the structure might collapse either due to flexure, due to failure in flexure, or due to failure in compression, or due to failure in shear, or due to failure in torsion. So basically it is failing due to the loads. And then we have serviceability. So what is serviceability? So the structure will become unserviceable. That means, suppose if I have a beam, and it will deflect in due course of time due to the loading, and again it will deflect. So at one point of time, this will become unacceptable. Okay. So at one point of time, this will become unacceptable. So then we will say that the structure is unserviceable. Because, okay, so that is called as limit state of serviceability. So either it will be due to deflection, or maybe more cracks will develop because of that, or due to vibration. Okay. So that is your limit state of serviceability. And then, okay, so then we have analysis and design of reinforced concrete beams. So this we have already seen in working stress method also. In this also we will have singly reinforced beam, doubly reinforced beam, and then singly or doubly reinforced flanged beams. So as I've already mentioned, in LSM you will also have T beams or flanged beams. Okay, so now coming to the most important part, the assumptions. Okay, so the assumptions in flexure we will see, like we have done the assumptions in working stress method for flexure. So now this is the assumptions for limit state method in flexure. So the first assumption is sections that are plane before bending will remain plane even after bending at any cross section. Okay, I hope this is clear to everyone. What is the meaning of this? This we have already discussed in WSM. Okay, can anyone tell me what is the meaning of this? Because this, since we have already covered this, so quickly someone can tell me, and then we'll move ahead. Yes, anyone? Sections that are plane before bending will remain plane even after bending. What does this imply? Meaning क्या है इसका?
Strain profile is linear.
Strain profile is linear. Exactly correct. So this implies that your strain profile remains linear. ठीक है, मैंने बताया था कि out of plane bending we are not considering. ठीक है, suppose if you have a beam and that beam will bend. ठीक है, so after bending the top portion will be in compression and the bottom will be in tension. So again if you take a section at that point, okay, so again after bending if you take a section तो उसका जो strain जो है वो uniform रहेगा. That means जो strain है that will be linear. So that is the meaning of plane sections before bending will remain plane even after bending. I hope this is clear to everyone. Now coming on to the next assumption, it is tensile strength of concrete is ignored. So this we have already seen, very simple. The tensile strength of concrete is not considered. And this is important. The third assumption, it says that the maximum strain in concrete at the outermost compression fiber is taken as 0.0035 in bending. Okay, remember it is mentioned in bending. So what does this mean? The maximum strain in concrete at the outermost compression fiber is taken as 0.0035. Okay, so when you draw the strain diagram, it means that the maximum strain will be 0.0035. So this is the assumption. Based on these assumptions only, we are going to design the structure for flexure, remember. So these assumptions are very important. Okay, so on the basis of these assumptions only, we are going to draw the stress strain diagram, and we are going to derive the equations, and then we are going to design the section. And the fourth assumption is the maximum strain in tension reinforcement at failure shall not be less than 0.87 Fy upon ES plus 0.002. I think this we have just now discussed. If you remember, the maximum strain in tension reinforcement shall not be less than this. So what does this mean? If you go to this figure, okay, so look here, the maximum strain. So what the assumption is saying, the maximum strain tension reinforcement shall not be less than this. मतलब strain इससे कम नहीं होना चाहिए, strain इससे ज़्यादा ही होना चाहिए in steel what we are using, because you know that steel is a costly material. So if you are using that steel, you should make sure that it yields. ठीक है, ये strain इतना क्यों होना चाहिए? So that the steel will yield. Okay, and then if the steel, you want the steel to yield, that is the reason you are using that steel in the structure. So this means जो maximum strain है वो इससे ज़्यादा ही होना चाहिए, इससे कम नहीं होना चाहिए. So this value I've already shown how this came. This is 0.002 plus ये part. ठीक है, now in case of mild steel we already know that the yield stress is properly defined, but in case of HYSG bars the yield stress is not distinct. ठीक है, the yield point is not distinct. So hence what we consider the yield stress as 0.2% of the proof stress. Okay, so remember this, the yield stress in case of HYSD bars we consider 0.2% of the proof stress. So 0.2% if you consider, so this will become 0.002. Understood everyone? So that is the reason we have taken a point from this, and when this point hits the curve, that is nothing but your yield stress. Is this clear everyone? ठीक है, ये point से if you take the line parallel to this, and when this line hits the curve, that point is nothing but your yield stress. And now from the design curve we are taking, remember, ठीक है, so design curve 0.87 से multiply करेंगे तो design curve मिल जाएगा. And now from this point if you take this, ठीक है, so this is the strain what we are talking about in the assumption. तो ये value कितना हो जाएगा? This is nothing but strain. So stress upon strain is nothing but modulus of elasticity. So strain is nothing but stress upon modulus of elasticity. So this is stress, this is upon ES. I hope this is clear to everyone. So that is the assumption we are talking about. The maximum strain in tension reinforcement shall not be less than 0.87 Fy upon ES plus 0.002. So if you understand this, it does not become difficult to remember this. ठीक है, if you know that curve तुम्हारे mind में है तो easily you will understand this. The next assumption is the relationship between the compressive stress distribution and the strain in concrete may be assumed to be a rectangular, trapezoidal, parabolic, or any other shape which results in prediction of strength in substantial agreement with the result of the test. ठीक है, so what does this mean? ठीक है, this means that, so as far as your test results are confirmed, ठीक है, so you can take any shape of the stress strain curve. Either you can take it as a rectangular, trapezoidal, parabolic, ठीक है, as unless and until it is in agreement with the result of the test. ठीक है, so here what we are considering, we are considering it as a, let me show you this. So this is the stress diagram, this is the strain diagram. So we are considering from the neutral axis it is parabolic up to a point, and then it becomes constant. Okay, so this is the stress block parameter stress diagram in LSM. ठीक है, WSM में कैसा था? Linear था. We know that the relationship is not linear. So here we are actually taking the actual relationship. ये non-linear है. So this part is parabolic and then it is constant. So maximum stress just now we have discussed, it is 0.446 FCK और maximum strain कितना था? 0.0035. ठीक है. So this assumption is saying that you can either take it as rectangular, trapezoidal, parabolic. So in this case, what we have taken parabolic and rectangular. Understood? So that was the fifth assumption. And the last assumption is the stresses in the reinforcement are derived from the representative stress strain curve for the type of the steel used. ठीक है. So this is nothing but this. ठीक है. Stresses हमने कैसे derive किया है? From these stress strain curve for steel. ठीक है. ये तो defined है properly, but here we have considered 0.2% of the proof stress, and then we have find out this. So those are the 6 assumptions for flexure on the basis of which you are going to design the member or design the beam. So is this clear, everyone? All the assumptions we have discussed. So after this, what we have to do is we have to understand the stress strain diagram and the stress block parameters. Okay, once you understand the stress block parameters, you will understand the equations for that, and after that we can actually go for the problems to solve the numericals. So now on the basis of this, this is the stress strain diagram. Okay, these are also called as the stress block parameters. Okay. So the strain diagram, we have already seen the assumption says that the maximum strain is 0.0035. It is 0 at the neutral axis, and as we go it will increase, and you already know that it is 0.002. ये 0.002 कैसे आया? Anyone? ये जो strain है, ठीक है, so this point is from this. ठीक है, ये जो इतना जो constant part है, ठीक है, ये constant part से if you take a straight line, so you will hit the strain curve at this point, and at that point the strain is 0.002.
सर वो 0.2% प्रूफ रेजिलियंस है उसका है.
Yes, come again, your voice is not clear.
सर वो टॉर स्टील का जो 0.2% प्रूफ रेजिलियंस है जहाँ से कब ड्रॉ किए थे सर, वो है ना?
No. ठीक है. So now if you pay attention in the stress strain curve, ठीक है, stress strain curve देखेंगे concrete का. ठीक है, यहाँ पे देखो ये इनका assumption है IS 456. What is saying that the stress strain curve for concrete is parabolic up to a strain of 0.002. ठीक है, and it is constant up to a maximum ultimate strain of 0.0035. Yes, everyone pay attention now. ये अभी तुमको stress strain curve, just keep this in mind. And now let us see the stress diagram. So now if you see that ये जो parabolic है, so this is parabolic up to a strain of 0.002, and then it remains constant up to a strain of 0.0035. Now you understood how this came?
यस सर.
Yes. What about others? Others also understood how this has been derived?
Yes, sir.
Just now I have told you कि ये जो parabolic
Yes, sir.
portion है, it is up to 0.002. So if you see this, I'll show you. अगर ये जो है इसको तुमने inverse कर दिया, ठीक है, ये curve को inverse करके इधर fit कर दिया तो exactly same हो जाएगा. ठीक है, ये जो curve था. Understood everyone?
Yes, sir.
Okay, fine. ठीक है, ये कर्व ऐसा कुछ था पैराबोलिक और फिर स्ट्रेट. ठीक है, यही इधर जाके इसको हमने सेम कर्व यूज किया है. ठीक है, ये जो था पैराबोलिक था 0.002 तक, और ये जो था ये 0.0035. सो आई होप दिस इज क्लियर. द स्ट्रेस ब्लॉक पैरामीटर्स. सो दिस द मैक्सिमम स्ट्रेन इन स्टील. ठीक है, ये लेवल ऑफ स्टील पे आएगा ये. ठीक है, व्हेन वी डू इट ऑन द पेपर यू विल अंडरस्टैंड. ठीक है, ये लेवल ऑफ स्टील पे ये तुम्हारा स्ट्रेन रहेगा. एंड देन यू नो दैट सिंस इट इज अ कॉम्बिनेशन ऑफ टू थिंग्स. ठीक है, ये एक रेक्टेंगुलर पोर्शन भी है इसमें. इफ आई मेक अ line over here, so you will get this rectangular portion and this parabolic portion. Correct? So इसके लिए now we have to find out the total compressive force and उसका location. ठीक है, टोटल कंप्रेसिव फोर्स निकालना है और वेयर इट इज एक्टिंग वो भी निकालना है, एंड द डिस्टेंस वी हैव टू फाइंड आउट. एंड दिस इज द टेंसाइल फोर्स विच इज इजी. stress into area 0.87 Fy we take it as. So now let us, yes, so X is the depth of the neutral axis, B is the breadth of the section, D is the effective depth of the section. So the depth of the neutral axis can be obtained by considering the equilibrium of the normal forces. Okay, resultant force of compression is stress into area 0.36 FCK B into X, and resultant force of tension is 0.87 Fy into AST. So force, when you equate Cu and Tu, ठीक है, if you just remember WSM में Cu force और Tu force को equate करेंगे तो neutral axis मिलेगा. So the same thing we have done here. We are equating the Cu force and the Tu force, then we are getting this neutral axis depth. Okay, so remember, whenever you have to find out the depth of the neutral axis, just equate C equal to T, where the resultant compression force is 0.36 FCK B into XU. And in the next, the lever arm, the distance between the lines of the action of the two force C and T is called as the lever arm and is denoted by Z. Okay, Z is given by D minus 0.42x. Okay, so if you find out this distance, ठीक है, ये जो C जो एक्ट कर रहा है उसका डिस्टेंस अगर टॉप कंप्रेशन फाइबर से निकालोगे, सो दैट कम्स आउट टू बी 0.42 XU. ठीक है, एंड द वैल्यू ऑफ C इज नथिंग बट compressive force is 0.36 FCK B into X. So now the moment of resistance with respect to concrete is compressive force into lever arm is given by this, and the moment of resistance with respect to steel is tensile force into lever arm is given by this. ठीक है, again the same thing, Cu into lever arm and Tu into lever arm. And then the maximum depth of the neutral axis, ठीक है, XU max, जैसे उसमें critical neutral axis निकालते थे, इसमें भी critical neutral axis निकालेंगे. So the maximum value, this you will get from the strain diagram. ठीक है, so if you consider the strain diagram, from similarity of triangles you will get this. So ultimately what you have to remember is the maximum depth of the neutral axis for different grades of steel, for Fe250, for Fe415 and Fe500. So for Fe250 it is 0.53D, and Fe415 it is 0.48D, and Fe500 it is 0.46D. Okay, so this how you got from this the limiting value of the depth of the neutral axis. ठीक है, ये कैसे मिला, strain diagram. Yes, if you see this strain diagram, ठीक है, so from this ये जो whole triangle है इसमें similarity of triangle you can use. ठीक है, so by similarity of triangle you will get this XU max. Now for a particular grade of steel, if you put the value of Fy for Fe250, तुमको एक XU max का एक equation मिलेगा. So that is nothing but this. So you have to just remember this, for Fe250 XU max का value है 0.53D, Fe415 के लिए XU max का value है 0.48D, and Fe500 के लिए it is 0.46D. ठीक है, similarly in this case MR का equation भी you will get it as directly. So now similarly limiting value of the tensile steel and moment of resistance. ठीक है, so MU limit with respect to concrete मतलब Cu into lever arm, and MU limit with respect to steel मतलब Tu into lever arm. ठीक है, this is what is important for you to remember, limiting moment of resistance. ठीक है, MU limit for different grade of steel, ये first row, this is important. So if you find out for Fe250 your MR will be 0.148 FCK BD square, for Fe450 or Fe415 not 450, for Fe415 it is 0.138 FCK BD square, and for Fe500 it is 0.133 FCK BD square. ठीक है, so basically you have to remember XU max का equation and this equation. ठीक है, two things you have to remember in this first row is important, while solving the problems. ठीक है, so for Fe250 the equation of MR is given by point, this is balanced MR, basically limiting MR or balanced MR is 0.148 FCK BD square. And the second thing which you have to remember is these values. XU max for grade of 250 0.53D, for 415 0.48D, and 500 is 0.46D. ठीक है, and then we have the types of problems. So this we already know. So what are the types of problems in LSM? Also we have the same type: determination of the moment of resistance, and then determination of stresses, and then design of the section. So these are the three types of problems we will see in LSM also. Okay, so that was all about LSM. So if you have any doubt in this, you can ask me. Yes, is this clear, everyone?
Clear, sir.
Okay, fine. Yes, what about others? You can use the chat box if you have any doubt. Okay, fine. Yes, equations we will derive afterwards. ठीक है, so in this lecture तो it is not possible because time तो हो गया है. ठीक है, equations we will derive. ठीक है, so just a second, I will show you how these equations have come. Last 4 slides. Okay, last 4 slides. ठीक है, so don't worry, I will show you this. Whatever I have shown you on the slides. ठीक है, I will show you by actually writing, so you will understand. ठीक है, इसमें सिर्फ मैंने जितना बताया था उतना ही याद रखो, इक्वेशंस के लिए मैंने बताया था. ठीक है, so now just give me a moment. How much time we have? Anyone? Yes. So now is it visible screen? Yes, all of you?
Yes, sir.
हाँ, so now in this you will understand it very clearly. ठीक है, so this is the MR of a singly reinforced balance section. ठीक है, so this is the strain diagram, this is the stress diagram that we have already discussed in the slides. ठीक है, so this is the strain value maximum 0.0035, और ये जो level of steel है इधर से, ये तुम्हारा strain है steel में Fy upon 1.15. ठीक है, ये 1 upon 1.15 एक्चुअली 0.87 हो जाएगा. ठीक है, तो ये है 0.87 Fy into upon ES plus 0.002, और ये है 0.446 FC के मैक्सिमम स्ट्रेस डायग्राम का, और ये जो 0.42 XU है. ठीक है, ये जो CU का डिस्टेंस है ये 0.42 XU है. ठीक है, एक्चुअली इसका भी डेरिवेशन है विच इज नॉट रिक्वायर्ड एक्चुअली. ये 0.446 FC और ये 0.42 कैसे आया? सो इफ यू सॉल्व दिस, ठीक है, इफ यू फाइंड आउट दिस CU टोटल फोर्स. ठीक है, बेसिकली अभी तुम्हारे पास दो पोर्शन है, एक रेक्टेंगुलर है और एक पैराबोलिक है, तो उसका तुम C1 और C2 करके करोगे तो तुमको टोटल CU मिल जाएगा. ठीक है, और सिमिलरली ये जो डिस्टेंस है तो C1 इंटू जेड y1 प्लस C2 इंटू y2 अपॉन C1 प्लस C2 करोगे तो तुमको 0.42 XU भी मिल जाएगा. ठीक है, दैट इज नॉट द इश्यू. ठीक है, सो अल्टीमेटली यू हैव टू रिमेंबर दिस स्ट्रेस डायग्राम. ठीक है, ये जो लीवर आर्म कितना है D माइनस 0.42, ये तो तुमको डिराइव करेंगे तो मिल जाएगा, और ये जो TU फोर्स है दैट इज 0.87 Fy इंटू AST. सो इसमें व्हाट इज इंपॉर्टेंट, जो हमने अभी इक्वेशंस देखा है, दैट डेरिवेशन ऑफ दैट इज इंपॉर्टेंट. तो फ्रॉम सिमिलैरिटी ऑफ ट्राइंगल्स ये 0.0035 अपॉन XU मैक्स तो तुमको ये मिलेगा. ठीक है, सो दिस अपॉन दिस D माइनस XU मैक्स. ठीक है, ये ट्राइंगल और ये ट्राइंगल का सिमिलैरिटी यूज किया, ये समझ में आया सबको? ठीक है, क्विकली यस बोलो, ये सिमिलैरिटी ऑफ ट्राइंगल है. एंड देन इफ यू डू दिस तो XU मैक्स के टर्म में तुमको एक इक्वेशन मिलेगा. ठीक है, इफ यू वर्कआउट दिस यू विल गेट दिस. अभी ये कैसे आया वो मैं बता रहा हूँ. 0.53D, 0.48D, ये सब कैसे आया? नाउ इफ यू कंसिडर FE 250, ठीक है, FE 250 के लिए FY कितना है? 250 है, सो यहाँ पे 250 पुट करो तो तुमको सॉल्व करने के बाद ये मिलेगा 0.53D. सो अल्टीमेटली व्हाट वी आर कंसर्न विथ दिस, ठीक है, दिस इज आई एम जस्ट शोइंग फॉर यू टू अंडरस्टैंड, दिस डेरिवेशन इज नॉट आस्क्ड इन द एग्जाम. तो 0.53D कैसे आया वो मैंने बताया. नेक्स्ट, अगर इफ यू कंसिडर FE 415, सो XU max यहाँ पे FY के जगह पे what you will put 415 and then you will get XU max as 0.48D. Similarly FE 500 के लिए FY का वैल्यू इधर 500 पुट करो, तुमको XU max मिल जाएगा. Is this clear everyone? XU max का वैल्यूज कैसे आया
Yes, sir.
और ये डायग्राम कैसे आया? ठीक है, नाउ लेट अस क्विकली गो थ्रू MR कैसे आया. ठीक है, MR इज गिवन बाय CU इंटू लीवर आर्म. ठीक है, CU मैंने बोला जो फोर्स है दैट इज 0.36 FC के B इंटू XU. ठीक है, अब ये 0.36 FC के B इंटू XU अब भी मैंने बताया कैसे आया. तुमको C1 इंटू ये करेंगे टोटल C1 इंटू Z, ये दोनों पोर्शन के लिए फाइंड आउट करेंगे तो तुमको टोटल C मिल जाएगा. ठीक है, तो यू कैन ट्राई दैट इसका डेरिवेशन, अदरवाइज इसका डेरिवेशन इज नॉट आस्क्ड, दिस इज इम्पॉर्टेंट. इफ यू स्टिल हैव डेरिवेशन अगर करना है तो वी विल डू इन द ट्यूटोरियल. ठीक है, सो ये CU इंटू लीवर आर्म इज नथिंग बट D माइनस 0.42 XU. नाउ अगेन फॉर FE 250 XU max कितना है? 0.53D. ठीक है, वी आर टॉकिंग अबाउट द बैलेंस्ड वन. तो XU max के जगह पे इफ यू पुट 0.53D देन यू विल गेट दिस फाइनल वैल्यू MR का. ठीक है, ये इंपॉर्टेंट है अपने लिए, you have to remember this 0.148 FC के BD square for FE 250 grade. ठीक है, ये तुमने इसमें इनपुट किया तो ये मिलेगा. सिमिलरली फॉर FE 415 अगर तुमने ये वैल्यू डाला इधर XU max का, so then you will get as 0.138 FC के BD square, and then for FE 500 you will get it as 0.133 FC के BD square. ठीक है, सिमिलरली फॉर टेंसाइल साइड क्या हो जाएगा? MR is equal to TU into lever arm. TU क्या है? 0.87 FY into AST, that is stress into area, and lever arm is D minus 0.42x, where XU is the depth of the neutral axis and MR is the ultimate flexural moment of the section and XU max is the limiting or the critical value of the depth of the neutral axis. ठीक है, is this understood to everyone? MR कैसे मिला? ठीक है, now we will see MR ऑफ एन अंडर इनफोर्स सेक्शन. ठीक है, सेम जैसे हमने WSM में किया था, एक तो MR बैलेंस के लिए चेक किया था और MR ऑफ एन अंडर इनफोर्स सेक्शन. ठीक है, तो MR ऑफ एन अंडर इनफोर्स सेक्शन हाउ टू गेट, so this XU should be less than XU max. This since we are taking it as an under reinforced section, you already know the concept of balanced under and over. So this is 0.446 FCK, this is 0.42 CU का distance and lever arm is D minus 0.42. To now get the value of XU, ये अभी तुम्हारा actual neutral axis है. ठीक है, actual neutral axis to find out we will equate CU equal to TU. CU मैंने बताया 0.36 FC के B into XU है, TU तो easily मिल जाएगा stress into area FY into AST. Now since we consider 0.87 and in LSM, तो XU का वैल्यू मिल जाएगा. So to find out the value of XU just equate CU equal to TU. ठीक है, ये अगर याद नहीं रखना है तो सिर्फ CU equal to TU करो and find out XU. ठीक है, अंडर इनफोर्स सेक्शन का XU मिल गया. नेक्स्ट, इफ XU इज लेस देन XU max, hence it is an under enforced section. ठीक है, and then MR is given by CU into lever arm. Okay, CU into lever arm, CU lever arm is nothing but D minus 0.42 XU, और MR is also given by TU into lever arm. ठीक है, 0.87 FY into AST into D minus 0.42 x. But remember in this case, if XU exceeds XU max, then you have to redesign the section. ठीक है, so you have to take care that XU should never exceed XU max. So this was all about the equations. ठीक है, बैलेंस का भी हमने चेक कर लिया एंड अंडर इनफोर्स सेक्शन का. So is this clear to everyone? ठीक है, लास्ट 5 minutes only are remaining. यस यस, सो ये जो सी यू का जो फोर्स है, दैट सी यू 0.36 कैसे आया, दैट इज उसका एक डेरिवेशन है. ओके, सो आई हैव ऑलरेडी टोल्ड यू, जो सी यू का जो इक्वेशन है 0.36 एफ सी के बी इंटू एक्स यू हैव अ डेरिवेशन फॉर दैट. ठीक है, एज आई हैव ऑलरेडी मैंशनड, ये जो पोर्शन है, ठीक है, इसमें दो पार्ट्स है, एक रेक्टेंगुलर पोर्शन है और एक पैराबोलिक पोर्शन है. करेक्ट. तो अभी रेक्टेंगुलर पोर्शन के लिए तुमको सी यू निकालना पड़ेगा, फिर पैराबोलिक पोर्शन के लिए सी यू निकालना पड़ेगा. ठीक है, उसको दोनों को ऐड करेंगे तो तुमको टोटल सी यू मिलेगा. ठीक है, यू हैव अ डेरिवेशन फॉर दैट, तो उसको डिराइव करना पड़ेगा. ठीक है, यू कैन ट्राई दैट, we will do that in the tutorial. So in this lecture we were basically covering the entire theory part. Okay, and what are the basics you need to know before solving the problems. Okay, anything else? Okay, I'll just give you the hint how to do this. You can try this. ठीक है, ये फर्स्ट इसको एक पोर्शन कंसिडर करो, ये रेक्टेंगुलर पोर्शन को, और ये सेकंड पार्ट को पैराबोलिक वी हैव ऑलरेडी कंसिडर्ड. तो ये टोटल एक्स यू है, इधर से लेकर इधर तक एक्स यू है. ठीक है, अभी ये रेक्टेंगुलर पोर्शन में कितना रहेगा और पैराबोलिक पोर्शन में कितना रहेगा वो फाइंड आउट करो. ठीक है, उसके बाद एरिया निकालो. यस, आर यू गेटिंग? ठीक है, उसके बाद यू कैन फाइंड आउट द एरिया. ठीक है, ये वाला डिस्टेंस तुमको मिलेगा, ये डिस्टेंस. ठीक है, दिस डिस्टेंस विल बी 3/7 एक्स यू, यहाँ से लेकर यहाँ तक, और यहाँ से लेकर यहाँ तक इट विल बी 4/7 एक्स यू. ठीक है, ठीक है, बेसिकली सी क्या है, फोर्स क्या है तुम्हारा, स्ट्रेस इनटू एरिया है. ठीक है, तो ये पोर्शन का स्ट्रेस इनटू एरिया करो रेक्टेंगुलर का, और पैराबोलिक का स्ट्रेस इनटू एरिया करो, तो तुमको टोटल सी मिलेगा. अगर वो तुमने पूरा कैलकुलेट किया तो तुमको मिलेगा 0.36 एफ सी के बी इंटू एक्स यू. Yes, anything else apart from this? ठीक है, you should make a note of this. ठीक है, make a note of this for MR of a singly reinforced balance section or MR of an over reinforced section. ठीक है, what is important is this, ये तुमको XU max का वैल्यू you have to remember. ठीक है, and yes, is my screen IS code is visible now to all of you?
Yes, sir.
Okay. ठीक है, तो इसमें if you go to section 5 limit state method, ठीक है, तो what we have done उसका थोड़ा सा पोर्शन इधर तुमको मिल जाएगा. ठीक है, so limit state method, limit state of collapse, ठीक है, कैरेक्टरिस्टिक एंड डिजाइन वैल्यूज, कैरेक्टरिस्टिक स्ट्रेंथ ऑफ द मटेरियल. ठीक है, लिमिट स्टेट ऑफ सर्विसेबिलिटी, डिफ्लेक्शन, क्रैकिंग, कैरेक्टरिस्टिक लोड्स एंड द डिजाइन वैल्यूज. ठीक है, डिजाइन स्ट्रेंथ एंड द डिजाइन लोड एंड पार्शियल सेफ्टी फैक्टर फॉर गामा एम, पार्शियल सेफ्टी फैक्टर फॉर लोड. ठीक है, सो इतना पोर्शन इसमें आईएस कोड में ऑलरेडी है. ठीक है, अपार्ट फ्रॉम दैट तुमको इक्वेशंस तो नहीं मिलेंगे इसमें, इक्वेशंस यू विल हैव टू रिमेंबर. ठीक है, देखो, नाउ कमिंग टू द लिमिट स्टेट ऑफ कोलैप्स फ्लेक्सर. ठीक है, assumptions you will get. ठीक है, assumptions what we have done, these are the stress strain curves. plane sections remain plane. ठीक है, maximum strain is taken as this. So all these assumptions are there for flexure in the IS code. ठीक है, so this you can find in the IS code. This we have already seen, deformed bars, steel with definite yield point मतलब Fe 250 के लिए. Yes, ठीक है. So in this case you will have the value of this. ठीक है, XU max का वैल्यू तुमको इधर से मिल जाएगा. ठीक है, for Fe 250 XU max is 0.53 D, for 415 0.48 D. Is it visible everyone? 500 और ठीक है. So this you can make the use of this. तो ये वाले वैल्यूज तुमको यहाँ पे मिल जाएंगे. बट वंस यू सॉल्व द प्रॉब्लम्स तो ये अपने आप तुमको याद हो जाएंगे. डोंट वरी अबाउट दैट. ठीक है, इसके बाद MR का इक्वेशंस तो तुमको याद रखना है. ठीक है, एक्सियो मैक्स का इट इज देयर. ठीक है, देन इट इज लिमिट स्टेट ऑफ कोलैप्स कंप्रेशन. ठीक है, कंप्रेशन के लिए अलग है. ठीक है, फ्लेक्चर का सो इतना पोर्शन यू ऑलरेडी हैव इन द IS कोड. ओके, इज दिस क्लियर नाउ एवरीवन? Because I think it's less than a minute left. So today we have done with the theory portion of limit state method. We have done all the assumptions, we have seen the equations. So in the next lecture we will actually solve the numericals. ठीक है, in the next